I'm Krisha.
And I'm Anita. We've been studying magnetic fields and electron beams in our high school physics class.
This is what we learned. We learned that the magnetic field can affect a force on a beam of electrons.
Well, we know that a TV uses a beam of electrons. Why don't we go try it?
Sure. So how about we try and hold up the north pole to the TV and see what happens?
The beam is being deflected away from its target.
It seems as if the electrons are bending the wrong way because it's the wrong color.
Why don't you try the south pole?
Ooh, it changed colors. It seems as if depending on which pole you bring to the TV, it changes colors.
Okay, well, a computer monitor is just like a TV. Why don't we try that next?
Sure, let's.
It's the same as a TV.
Why don't we try a flat panel?
Okay.
No effect. I guess this technology doesn't use electron beams.
Well, we have cathode ray tubes in the physics lab. Let's go try that. These simple cathode ray tubes are like a primitive TV or computer monitor. We can't actually see the electrons, but when electrons collide with the phosphorus chemicals in the tube, it gives off light.
That must be how light is produced on our TV screens. You know?
North causes the beam to bend downwards, and it looks perpendicular to the direction of the electron's motion.
Try south. Oh, it's opposite. I wonder how we could predict what way it would move.
I think we'll learn how to predict the direction of deflection in today's physics class.
The magnetic field and the magnetic force. Be sure to indicate the point of view of the observer. I'll do a side view. I'll make my electron beam travel from left to right. Make sure you always label your vector arrows. I'll have my magnetic field directed into the board. I'll use an X to indicate an arrow that's going into the board. Now I'll use my left hand to predict the direction the electron beam is to be deflected. The thumb represents the direction the electron beam is traveling. The fingers indicate the direction of the magnetic field. This causes the palm to point downwards, and this is the direction the electron beam is forced to move. I'll try it once more. I'll still have the electron beam travel from left to right. I'll have my magnetic field directed out of the board. I'll use a dot to indicate an arrow coming out of the board. The thumb represents the direction the electron beam is traveling. The fingers indicate the direction of the magnetic field. This causes the palm to point upwards. Upwards is the direction.
We've seen that the magnetic field will deflect the electron beams. All we need to test, though, is our left-hand theory to see if it actually does do the right prediction.
Well, here's the cathode ray tube.
Okay, north first. My thumb represents the direction of the electrons are going, left to right. My fingers represent the direction of the magnetic field, north to south. And my palm, facing downwards, therefore should represent that it's being deflected downwards.
Okay, well, let's test the prediction. We'll do north first. You were right.
So for the south pole, my thumb represents the direction of electrons flowing, still left to right. My fingers representing the direction of the magnetic field, which is still north to south, but my palm is facing upwards. Therefore, the electrons should be traveling upwards.
Okay, well, let's test the prediction.
Upwards? Oh, we're good.
All right. Not only do we know that a magnet will exert a force on a beam of electrons, we are also able to predict the direction of the force.
So in other words, yes, we can predict the direction of the beam.
I think we'll learn how to predict the direction of... Okay. Again. What's wrong with it?
This might help.
Oh.
Okay, well, first of all, in our lovely physics class, we learned that the magnetic field... Oh, okay. on.